Alright, we're going to try this one more time. We got complex ion notes. Just to catch you guys up, we got a coordination compound that has a complex ion, which is a transition metal with various ligands attached to it that can be positive, negatively, and neutrally charged. And they are Lewis bases, meaning electron paired donors. Looks like it's working. The video is working. I won't mention that it is Friday the 13th. So we'll buck that little trend. So then you got this complex ion. It's either overall plus or minus charge. It's attached to another ion to make it an overall zero charge. And that's the coordination compound. So we got primary valence is the oxidation state. Secondary valence is the coordination number. So basically the oxidation state of the transition metal is super important. And then the other thing that's important is the number of bonds coordinate bonds can form with its ligands, the transition metal and its ligands. Alright, so that's what we covered so far. So then we got to talk about what is a ligand. Well, it's a Lewis base. Lewis base, not or, but also known as an electron pair donor. See if I got that. Oh yeah, more specifically, it's a neutral molecule or ion having a lone electron pair that can be used to form a bond to a metal ion. So that's the technical definition. Essentially a Lewis base. It could be positive, negatively, or neutral. Alright, a ligand can be thought of as a Lewis base, which donates a lone pair of electrons. What do we got here? So here's an example of not a coordination compound. This would be considered simply just a complex ion. You got silver, and you've got ammonia and ammonia attached. Ammonia is neutral, and silver is always going to be +1 naturally. So our complex ion charge, oxidation state, is +1. So the bond between the ligand and the metal ion, or Lewis acid and base, is called a coordinate covalent bond. Coordinate covalent bond. Oh my gosh, we can't see it. There we go. Alright, then we got these crazy words like monodentate ligand and bidentate ligand. Key is mono, bi, 1 versus 2. So monodentate just means you got one ligand. So it's a ligand that can form just one bond. And what bond are we talking about? We're talking about a coordinate covalent bond, just one. So ammonia is looking like, and we're going to talk more about this in the bonding unit, which comes after Thanksgiving. It only has one lone pair of electrons, and so it's a monodentate ligand. Whereas H2O, here, let me show this. You guys probably recognize this from sophomore chemistry. This is the bonding shape of ammonia, and you got one pair of electrons that is available for forming this bond. Whereas H2O, for example, is going to be written like that, and we have 1, 2 pairs, lone pairs of electrons that can be involved in this coordinate covalent bonding. So that would be an example of a bidentate ligand. So it's a ligand that can form 2 bonds. And the bonds we're talking about aren't ionic, they're coordinate covalent bonds. So that's this complex ion stuff in a nutshell. The rest that we're going to get into is how do you name it and how do you write the formula of it. And it's kind of fun because it's like a little puzzle. It's like Sudoku. When I'm retired and old, I am going to be a Sudoku pro. I'll join all these Sudoku groups. Alright. Okay, so here's like an example. Ooh, who can say that 20 times fast? It's a little tongue twister. We got ethylene diamine.
I'm in Bob's counter.
All right, Dobson, you got it?
Come on, Dobson.
Oh, he can do it. Ethylene diamine tetraacetate.
Yeah.
There we go.
David, you were so close.
So close. EDTA. So this is basically organic nomenclature. We'll get into that. Different schedule this year. So sometime in 2021, providing our winter's not too dark, we'll get to it. So, hexadentate ligand. Whoa, hexadentate. Hexa means 6. So this EDTA is a huge organic molecule with a lot of different potential for bonding sites. We're not going to be dealing with that. We're going to pretty much be focusing with monodentate most of the time, and some bidentate. Forms very stable complex ion, used to remove toxic heavy metals from the human body, and used as a reagent to analyze solutions for their metal ion content found in many products such as soda, beer, salad dressing, bar soaps, and most cleaners. So it's very cleansing. So I won't mention about the beer because, well, this is on video. All right. Cation. So here's naming coordinate compounds. This is where it gets really fun. I'm not going to read all this. We're going to go back to all of these. These are the rules. And all right, so we got cobalt. We got 5 amines. So there's so many different ways to say the same thing. You got NH3 is ammonia, but when it's a ligand, it's called an amine. And it's a very, very, very common ligand. So through experience, you'll just know, oh, NH3 is amine. That's kind of how it is. I think on the test, what I'll do is I'll put a little word bank. Amine equals NH3. If I forget, let me know. But I'll put it on my list to do. And we got chlorine, and then the chlorine outside. So it looks like complex ion is this main thing except for the 2 chlorines outside. So cation is named before the anion. That's no different from any ionic compound. So we're going to name, I'm assuming this is the cation because it's put first. That's usually how we do it. So we're going to name this one first, and we're going to name this one second. So I'm going to put this right here, chloride, because that's the second part. You just name the ending, change the ending to IDE, chloride. All right. So now we got to figure out what's the name of this complex ion. It says ligands named before the metal ion. So that means cobalt is going to be named last in this complex ion. We're going to have to name the amines and the chlorines first. All right. In ligands, an O is added to the root name of an anion. NH3 is neutral charge. If you're not sure, we can double check ourselves. Typically N is -3, H is +1. They're balancing each other out, so it's a 0 charge. So it's not either. So, but chlorine, that's a -1 charge, that's an anion. So we're not going to call it chlorine, we're going to call it chloro. But before we start writing chloro and amines places, we got to figure out the prefixes. Mono, di, tri, tetrapenta, and so on, to know the number of simple ligands. So, yeah, we do mono. So, it looks like it's going to be monochloro. Let me just double check. Yeah. I got to change that there. Because if you just have one, you don't necessarily need a prefix for naming this. So we're not going to need monochloro for that one. But we do need the penta for the amine. But then which one comes first, the chloro or the amine? Let's see. Does it tell us in these directions? Here it is. That's talking about the oxidation state of the total complex ion is going to be denoted by a Roman numeral, but we'll get back to that one. When more than one type of ligand is present, they are named alphabetically. So amine or chloro, which one comes first? Amine. So we're going to do pentaamine. All right, and I guess we'll do double A. I'm not going to knock you if you have just one A. All right, so we got pentaamine, chloro, one word. Pentamine chloro. We're not going to do mono because it's redundant, apparently. Who says that we can't have mono in there? Well, if you really want to know, in 1919 they come up with this nomenclature thing. And what is it? The IUPAC, International Union of Pure and Applied Science, international panel came together and decided this is how it's going to be. And if you weren't there, then you don't have a say. So that's where these rules are coming from. A group of people decided it. Oh my gosh, get this box out of there. Oh, Braden is in here. All right. Glad you're in here, Braden.
Yeah, I've been in here.
Oh, really? I knew that, yeah. So we got pentamine chloro, and now we got to do the transition metal, which looks like it's cobalt, chloro, cobalt, and I accidentally made it capital because I really like cobalt, but it's one word, so it really should be lowercase. Sorry about that. Lowercase. We got to show the charge of this thing. Alright, so amine is 0 charge, not going to impact it. But then chlorine is -1. Okay.
Mr. Hebner.
Uh-huh.
Ryan Swanson said that his internet went off the group.
Oh, man. Alright. He was probably writing something political. You got to do that on your own computer, so.
Yeah, because then you get censored otherwise.
Exactly. So.
And then you get banned on Facebook.
Yeah, there's not much I can do on Facebook, so I got a Parler account now, so I can actually say something in Parler. So, it's so weird, isn't this America? It's sad, sad. All right, so we got pentamine, chloro, cobalt. We're trying to figure out what the charge is, so we can put that into the Roman numeral. So we're going to have to go backwards in analyzing this. We got chlorine is -1, and there's 2 of them, so it's an overall 2 minus that the complex ion has to be, offsetting at least. So because we got 2 minus for the chlorine, the complex ion, including this chlorine, has to be overall 2 plus. All right, here, let me write this so it's a little less confusing, hopefully. This is the complex ion, just dissecting this part. And it's an overall 2 plus, we said it has to be. So now we want to figure out what's the charge of cobalt. So we could mathematically determine this, saying 2 plus equals X for cobalt and -1 for my chlorine. So in this case, it looks like X would equal 3. Because we got to add 1 to both sides, X equals 3. So that means my cobalt would be a Roman numeral 3. And if you can do it in your head, that's great. This is kind of working it out, thinking out loud. Questions on how I got 3? Like, it's one of the trickier parts. All right. Hey, there it is. And we already wrote our ending, our anion chloride. That was probably the easiest part. We got pentamine chlorocobalt 3 chloride. That's the name of the coordination compound. All right. If you weren't having fun with that one, well, then this next one is just for you. So this one's there. Uh-huh.
I would like to take a shot at the other chemical name.
Oh, this one?
The first one.
Oh, yeah. Oh.
All right, ready?
I'm ready.
Ethylene diamine tetraacetate.
Nice.
Let's
now you
go,
just gotta,
David. Let's go.
Yeah. Now you just got to say it 10 times in a row.
Ethylene diamine tetraacetate. Ethylene diamine tetraacetate. Ethylene diamine tetraacetate. Ethylene diamine tetraacetate.
Let's go,
There you
David.
go.
Woo!
Yeah, that's probably better than I could do. Got at least 5 of them in there. Nice. So organic will be a fun unit. We're focusing on naming, formula writing for organic. All right, so for this one, hey, this is opposite because we've got potassium is not a part of the complex ion, so we're starting with the cation. We're going to name it right away potassium. Get that out of the way. All right, and then we got FeCN6, so it looks like that's going to be our complex ion. And now we got some more curveballs coming, but we do have 5 minutes, I think, to do it. So, going back, cation is named before the anion. All right, we got that. Ligand's named before the metal ion. What's the ligand? That's a polyatomic ion cyanide, and it is negatively charged, Cn with a -1 charge. So it's got to be not cyanide, but cyano. Cyano. So we got potassium. How many of them are there? Oh, there's 6 of them. So when there's not more than one ligand, so that doesn't matter. But then there's 6 of them. Hexacyano. And then we got to do the transition metal. But the thing about this, and I'm going to put this in the list that I give you. Yeah, it's annoying because if you have a negatively charged, wait, does it say in here? Oh, it does. Hey, if the complex ion has a negative charge, the suffix 8, suffix is the ending part of the word, 8 is added to the name of the metal. So, okay, so this should be hexacyano iron 8, right? No, so they have some of the old nomenclature that's kind of just clinging on, and you got to call it ferrate. So if it's an iron complex based, or an iron-based complex ion, you got to do ferrate. And yeah, so I'll put that on the little cheat sheet that's on your test, because I don't think you're going to have to memorize something like that. I don't think you're going to have a naming question on the ID test in May, but you probably will have some sort of question involving complex ions. So.
Why don't you have to put the prefix in front of potassium?
Because it's a cation not involved in the complex ion. So technically your complex ion is just this. So potassium is just like chloride was in the previous problem. It's the other ion that's not the complex ion involved in this coordination complex. So, or coordination compound. Yeah, so it's different because our ion is the cation, whereas here our individual ion was the anion. So neither needed a prefix. I don't know, does that answer?
Yeah, thank you.
Okay. All right. Hexacyanoferate instead of ironate. Do we need the Roman numeral? Yes. All right, so now we got to figure out cyanide. There's 6 of them. Let's just do this. -6 because there's 6 of them. So then this has to be +6. But, yeah, that would be +6. Oh, yeah. Oh, weird. Yeah, so iron is +6 in that case. That's not very common. Usually it's like +3. That being said, well, wait. No, it wouldn't be that. No, here, let's do it mathematically. So we got +3 for our potassium, and the overall is 0, okay, and +x for our iron, we don't know what that is, plus -6 for our 6 cyanides. All right, so 3 minus 6 is -3, 0 equals x -3, +3 to both sides, x equals 3. All right, that makes more sense. I was going to say 6 for iron. That doesn't make sense. Okay. Questions on how I got the charge for iron? So when in doubt, just write the math out.
Mr. Junior, how do you know it's supposed to be like a 0 charge overall?
Oh, because a coordination compound is balanced. So it's just like an ionic compound, NaCl, overall 0 charge. All coordination compounds are 0 charge.
Okay.
The thing that's not going to be a 0 charge is the complex ion portion of it. Yeah. So that is a perfect segue to ending this class. So we'll do some more fun practice on Monday, hopefully face-to-face, although you never know. Our principal said that predicting what's going to happen on Monday is like being a meteorologist. So. All right, hopefully you have a great Friday the 13th, and I'll see you guys Monday.
Later, Mr. Huebner. Thank you.
No problem.
Yeah, thank you very much.